Hey everybody, this is Mrs. Snook, and this is a section 6.3 day 2. So we're going to finish off vectors in the plane. And today we are going to work on 3 skills. We're going to find unit vectors. We're going to write a vector as a linear combination of unit vectors. And we're going to find the direction angle of a vector. So let's get started. Unit vector, what that means is the vector is exactly 1 unit long, so magnitude is 1, and it goes in the same direction as your normal vector. And the way you can find a unit vector is you take whatever your given vector is and divide it by the magnitude. That then makes the magnitude of your resulting vector 1, and it goes in the same direction as the original vector. So here's our first example. We're going to find a unit vector in the direction of vector v, which is written in component form as -2, 5. So what I need to do is find the magnitude of vector v, and then I need to divide that vector by its magnitude. So here we go. Magnitude of vector v, that's going to equal square root of -2 squared plus 5 squared. Because in the component form, -2 is how far it goes in the x direction, and then 5 is how far it's going in the y direction. So using Pythagorean's theorem, I can just square them, add them up, and take the square root. So I then get the square root of 4 plus 25. That gives me square root of 29. So that's the magnitude of vector v. Now what I need to do is take each component of vector v, divide it by its magnitude. So then when I do vector v and I divide it by the magnitude of v, what I'm going to get is, I'm going to write this in component form, -2 over the square root of 29. 29, not 5. And 5 over the square root of 29. So that's our vector as a unit vector. Now, I would prefer that you didn't leave the radicals down there. So go ahead and rationalize. And when you rationalize, you're going to get this. That's going to be -2 root 29 over root 29 and 5 root 29 over root 29. Okay? The next idea is what's called standard unit vectors. And we have a standard unit vector that is exactly 1 unit long, and it goes in the positive x direction. And that one is I. And I write it like that. I write an I with a little caret on top, and that is the unit vector in the x direction. We have another one called J, and I write it like this. I write a J and a little caret on top, and that's the unit vector in the y direction. And what this does for us is we can then write our vectors as in terms of these standard unit vectors. And then as we go forward in this chapter, we're going to have a nice, easy way to multiply vectors when we have them written in terms of I and j. So here's an example. We're going to have vector u. Its initial point is at 2, -5, and its terminal point is at -1, 3. And we're going to write this as a linear combination of the standard unit vectors. Now last time what we did was this. We would have said vector u equals, and then as components, we would have subtracted like that. So it would have been -1 minus 2, because we're starting at 2 and we're landing at -1. So -1 minus 2, that would have been in the x. And then the y would have been 3 minus -5. We're going to do the same thing here, but now I'm just going to write it in a different notation. I'm going to use the i's and j's. So here's my vector. -1 minus -2 is -3. 3 minus a -5 is 8. So then as the combination of my standard unit vectors, I would say vector u equals -3i plus 8j. We can also do vector operations with our vectors written in these forms. Makes it super easy. So we have u vector, which is negative 3i plus 8j, and the v vector is 2i minus j. And we're going to find 2u minus 3v. Okay, so 2 times vector u is going to be 2 times negative 3i plus 8j. And then all I have to do is just distribute this 2. So I'm going to get negative 6i plus 16j. That's a j. Now let's find 3v. This is a negative 3v. And v is 2i minus j. So again, just distribute that negative 3, and I'm going to get negative 6i plus 3j. Okay, now all I have to do is add these together. So then my 2u, vector u, minus 3 vector v is going to be, I have a negative 6i plus 16j. That's my 2u. I have minus 6i plus 9j. That is my minus 3v. And now think of it as combining like terms. I have a negative 6i and a negative 6i. That's a negative 12i. And then I have a 16j plus a 3j. I don't know where that 9 came from. And that's going to give me a 19j. So here is my vector 2u minus 3 vector v, and I've written it in the standard form with the i's and j's. All right, the last thing that we need to do is figure out the direction angle of a vector. Super, super simple. You totally got this. So because the I goes in the x direction and the j goes in the y direction, what we really have here is an x and a y. So just like you did back in chapter 4 when we were doing trig functions in the coordinate plane, you can say tangent of theta equals, you're going to take the coefficient of the I vector, which is 3. You're going to divide it by the coefficient of the j vector, which is also 3. So you're going to get tangent of theta equals 1. Now grab your calculator, do the inverse tangent, and your angle is going to be the inverse tangent of 1. And if you're in degree mode, you're going to get 45 degrees. Okay? Now we're going to do another example, and this time our vectors, we have 3i and minus 4j, so they have different coefficients in front of them. It's going to work the same way. Take the coefficient in front of the j, that goes in your numerator. So tangent theta equals negative 4. Take your coefficient in front of the I, that goes in the denominator. So tangent theta is negative 4/3. Grab your calculator. Do the inverse tangent of negative 4/3. So inverse tangent, 4 divided by 3, I got 53.1 degrees. And those are the direction angles of our vectors. Okay? There's only one more problem I want to do with you, and that's a real-life application. In our picture, we have an airplane descending, so I imagine they're landing at SeaTac. And we're going to find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour and an angle of 30 degrees below the horizontal, as shown in our figure. So in our figure here, we're 30 degrees below the horizontal. That works out to 210 degrees. And the magnitude of this vector is 100. And we're trying to break this into the component form, which means I'm going to have a vertical component here and a horizontal component here. My horizontal vector is going to go that way. My vertical vector is going to go that way, which means that I'm going to have a negative coefficient in front of I. So my final vector is going to look something like this. Something that's negative in front of the I vector. And then we're going to have something else that is negative in front of the J vector. And once I have that, I'll have my answers. So what I'm really trying to do is find the lengths of these sides with my hypotenuse as 100. So here's my 30 degrees in here. I'm trying to find my J vector here. Remember, good old-fashioned SOHCAHTOA, this is opposite, this is hypotenuse. So I'm going to say that, I'm going to call B. So this is going to be a B, this is going to be an A. So B is going to be, let's go ahead and, I'm going to do it like this way. I'm going to say the sine of 30. I've got opposite over hypotenuse is going to be B over 100. So then all I got to do is take that 100, multiply it by the sine of 30. And I get 50. So I know that my plane's, the standard vector for going up and down is going to be a negative 50. So I have a negative 50J. Now I need to figure out A. Well, I still have my 30. A is going to be right here. That is adjacent with hypotenuse, so now we're talking cosine. So cosine of 30 is going to be A over 100. A is going to be 100 times the cosine of 30. A equals, grab your calculator, 100 times cosine of 30. I got 86.6. And remember, this is going this way, so it's going to be a negative. So when I write my final answer, I'm just going to put it here, 86.6. So here is our vector for our velocity of our airplane landing at SeaTac, minus 86.6I minus 50J. And that is it for today. Thank you for watching and have a great day.